Hi, my name is Marcus. I'd like to thank Dr. Chalicia for the support and help throughout the semester. I'd like to present to you about my end semester presentation on my final year project topic, that is numerical analysis on smoke behavior and fire spread in a longhouse. Longhouses are prone to fire risk, and it is one of the largest risks recorded to longhouse. According to a study done by Zhang in 2019, it was recorded that more than $10 million of losses and one death due to fire in a longhouse. Besides that, victims who are exposed to fire scene are prone to face death risks from inhaling smoke rather than burns. According to a study done by Archer in 2019, an estimation of 50 to almost 80% of fire risks are related to the inhalation of smokes from the victims rather than suffering from burns. Moving on, the problem statement of this topic is the application of fire dynamic simulator modeling has increased over the years due to the advancement of fire simulation and also due to the loss of lives and goods to fire cases. More and more attention are being paid to study about the smoke behavior and also the fire spread pattern to understand and study more about real case of fire. The objective of this topic is to create a 3D model of a longhouse with the correct dimension, with the correct properties, and correct combustion parameters, and to conduct a simulation on the longhouse in a real fire case and analyze numerically the smoke behavior and fire spread in the longhouse using fire dynamic simulator software. The diagram below shows the preliminary result of the simulation. This is what to be expected to see at the end of the final year project. Moving on. Now I would like to talk about the literature review of this topic. Firstly, talking about the smoke behavior, there are two types of smokes: hot smokes and cool smokes. The hot smokes would spread quickly to the ceiling, forming a big layer of hot smokes while reducing visibility of the victims and pulling clean and cool air from below. Cool smokes are the complete opposite of a hot smokes. It has very slow movement when compared to hot smokes. Cool smoke zones are zones that allow hot smokes to move to travel to, and cool. Besides that, based on previous research and standards written by researchers and professionals, the spread rate function that is present in the fire dynamic simulator is able to replicate a real fire case that replicates a fire that expands radially. Based on standards, the heat release rate that would be used in this topic would be based on the standards written. The heat release rate and other combustion parameters. The heat release rate that will be used would be 250 kilowatt per meter square. The fire growth rate would be 0.0469 kilowatt per second square, and the fire spread rate calculated that would be used in this topic later on would be 0.0077 meter per second. The software that I will be using in this topic would be Fire Dynamic Simulator, as it has helped fire safety professionals and engineers and researchers around the globe to solve fire safety problems and also to study more about fire dynamics. Besides that, FDS, in short of a fire dynamic simulator, is able to model smoke movement, fire growth, and fire spread patterns to help people to visualize the movement and also the visualize the movement and patterns to be analyzed later. Moving on to methodology of this topic. After understanding the problem statement, the longhouse dimensions is defined. The dimension is defined based on a research done by Anjang, and the dimensions of the longhouse are followed very closely based on the study. Then, a fire source location is defined to be in the middle of the longhouse to replicate a worst fire case scenario. And then, coding will be studied and input into fire dynamic simulator. After that, simulation will be done on smoke view and the results will be displayed. If any error is encountered in the results or wrong results are displayed, I will go back to study more about the coding and figure out the errors in the results and figure out how to solve the error in the results. Then if correct results were displayed, the numerical analysis will be conducted, results will be tabulated and analyzed and discussed. The expected outcome of this topic is the successful and valid simulation of a real fire case in a longhouse, and also it is expected to have a successful numerical analysis with valid results extracted. In the next semester, I will continue working on the simulation, and also I would finish the simulation with all the correct combustion parameters so that the analysis can be done numerically and also valid data can be extracted. And that's all from me. Thank you.